So this video lesson attempts to construct and break down how place value works within the decimal system. Now, generally, when we talk about decimals, we hear it refer to those parts of numbers that are greater than 0 but less than 1, referring to halves, 3/10, 73/100. Words like that are familiar and used often with the term decimal. Officially, though, decimal just refers to the fact that our numbers are based around 10, and our place value system is based around 10. So to talk about decimal place value, we're actually talking about the place value of the entire counting system. This video, however, specifically looks at those numbers that are between 0 and 1. So let's take a look at the place value for whole numbers specifically and use that to break down the place value for decimals, for parts of numbers. Now we can see in this graphic here and understand that our place value system is in fact based in 10, because when we start out with our basic unit, which is ones, we reach 10 ones, we add another unit to the tens column because there are 10 ones for every 10. Similarly, if we reach 10 tens, we start adding to the hundreds column because every 100 represents 10 tens. And so it goes on and on and on up through 10,000s, 100,000s, millions, billions, trillions, as large as you want to go. Our place value system will still always be represented by each new place value is 10 times the place value before it. Now, if we look backwards from the larger numbers to the smaller numbers, this is how we're really going to break down what the place value system is for numbers less than 1. We can see that if it's true that it takes 10 hundred-thousands to make a million, then each of these 100,000s represents one of 10 equal parts that makes a million. Let me say that one more time. If there are 10 hundred-thousands for every million, so we'll represent here 10 times HT for 100,000 equals a million. If there are 10 of those for every million, then each of these 100,000s represents one of 10 equal parts that makes up a million. And so it continues down through 10,000s. There are 10 10,000s and 100,000. So a 10,000 is 1/10 of 100,000. It represents one of 10 equal parts of 100,000. And on through the thousands, hundreds, tens, and ones, and we've arrived at the smallest place value that we have for whole numbers. The question now then is, what if we keep moving on to the right? Can we continue this pattern and this process where to find the next smaller place value, it represents 1/10 of the place value before it? On and on and on. What happens if we want to go one more place value to the right? Well, we know that there are 10 ones in a 10. So a 1 represents 1/10 of a 10. Well, it seems pretty natural that we should want to talk about the next smaller place value as 1/10 of a 1, because whatever it is, there are 10 equal of these place values that make a 1. So whatever it is 1/10 of a 1. And it turns out that's actually how we refer to the place value system. And we can go on and on and on and on and on. And we'll take our system out to the millions. And the place value system for the decimals, for the smaller than 1 parts, works exactly the same as it does for whole numbers, where if you start with the value on the right, it takes 10 of them to make the next larger place value, and on and on and on. So, if you notice, I'm going to draw your attention to this here, that not only does the place value system work, but if we take a look at the ones, and now let's look at the place values that are immediately on either side of the ones. To the left, to the larger side, is the tens. It takes 10 ones to make a 10. On the right-hand side are the tenths. It takes 10 tenths to make 1. So 1 is 10 tenths, and 10 ones make a 10. If we continue on to the left, we reach the hundreds, and 10 hundredths make a tenth. 10 thousandths make a hundredth. 10 hundredths make a tenth. 10 tenths make a 1. And so if we break that down even further, not only do 10 tenths make a 1, 100 hundredths, 1,000 thousandths, 10,000 ten thousandths make 1. And so the 1 in the center next to the decimal point that separates the two more or less can be viewed like a mirror, where to the immediate larger end of the 1 is the 10, to the immediate smaller end is the tenth, and continuing outward from the 1 in either direction. In the larger, the smaller direction, we have hundred and hundredth, thousand and thousandth. And in any of those cases, it takes 1,000 ones to make 1,000, and it takes 1,000 thousandths to make a 1. So the 1 almost acts like a mirror. So let's look at this visually, though, from the ones and break down specifically what it takes to make a tenth and a hundredth. Well, if this box here represents a 1, and we want to represent 10 equal parts of a 1, which would be our tenths, we can just split this 1, say, into 10 columns. Each of these columns represents 1 of 10 equal parts that make up a 1. Now, you've seen the blocks, perhaps, with a place value system where 10 of these small cubes are elongated to make a 10. Well, in this case, we can break down one of these ones into 10 tenths. And so 10 of these tenths will make a 1. Now, if we wanted to make a hundredth, we need to make each of these tenths into 10 equal parts, because a hundredth represents 1 of 10 equal parts that makes a tenth, or 1 of 100 equal parts that makes up a 1. Well, if we split each of those 10 columns into 10 equal parts, then we can create the hundredth of a 1. So if you wanted to go through and count each of the blocks in here, you could. There are 10 rows of 10 columns, so there are 100 blocks here. But each of these little blocks now represents a hundredth. One of these hundredths represents 1/100th of a 1. And it takes 100 of these hundredths to make a 1. 10 of these tenths to make a 1, and 1 of these ones. And that is how we break down the place value system for decimals that are smaller than 1, using the exact same rules, and I'll get rid of all this here so you can see it, using the exact same rules as we did for whole number place values, except now referring back down to place values that are smaller than 1. Each column to the left is 10 times the value of the column to the right, and each column to the right is 1/10 the value of the column to the left.